a railroad crossing somewhere in the Great Plains. The gates are down. A freight train rolls through, car after car, for 10 minutes straight. Somewhere in the middle of that train, painted on the side of a tank car in white letters, 3 words: "Do not hump." Everyone who has waited at a crossing has seen it. Most people laugh. Nobody knows what it means. Those 3 words are a federal regulation. Title 49, Code of Federal Regulations, Section 179.400-25. The government requires them on both sides of certain tank cars, in letters at least 1.5 inches high. They exist because somewhere in this country, right now, a railroad is building a freight train by crashing cars into each other on purpose. That process is called humping, and the engineering behind it is one of the most brutal, elegant, and hidden systems in the American supply chain. Have you ever seen those words at a crossing and wondered what they mean? Tell us in the comments. This is what American Iron Works covers. Subscribe so you do not miss what comes next. A freight train arriving at a major rail yard is not a finished product. It is a collection of cars headed to dozens of different places. One car goes to a grain elevator in Kansas. The next goes to a port terminal in Houston. Behind that, a tanker headed for a refinery in Louisiana and a boxcar bound for a warehouse in Chicago. Every single one of those cars has to be separated from the inbound train and placed on the correct track to join a completely different outbound train. The slow way to do this is called flat switching. A locomotive grabs one car at a time, backs it onto the right track, uncouples, rolls forward, grabs the next car, and starts over. Track to track, car by car. A flat yard can sort a few hundred cars in an entire shift. Think about what that means for a yard like the one in North Platte, Nebraska, where 14,000 cars pass through every 24 hours. At flat switching speed, you would need dozens of locomotives running non-stop, burning fuel, wearing out track, and still falling behind. The math does not work. The railroads needed a system that could sort thousands of cars per shift with a single locomotive doing the pushing. In the 1870s, American railroads found a different way. They built a hill. A hump yard is a classification yard with a man-made mound of earth built across the tracks. Most humps rise 15 to 20 feet above the surrounding yard. The biggest one in the country stands 34 feet tall at Bailey Yard in North Platte, Nebraska. The concept is older than the automobile, older than electric light, and older than the telephone. The process works like this. A locomotive pushes an entire inbound train toward the crest of the hill at 1 to 2 miles per hour. The train creeps forward. At the top, a worker uncouples a single car or a small group of cars headed for the same destination. The locomotive keeps pushing. The uncoupled car tips over the crest. Gravity takes it from there. No engine is attached, no one is riding inside. A 100-ton steel box is now rolling loose through a rail yard under nothing but the force of a hill and the weight of its own cargo. The car rolls downhill into a spreading fan of tracks called the classification bowl. The single track at the top of the hump divides into multiple paths through a throat of remote-controlled switches. A computer in the yard tower knows where every car is supposed to go. It lines each switch automatically milliseconds before the rolling car reaches it. At Bailey Yard, there are 114 destination tracks in the bowl, 65 for eastbound trains and 49 for westbound. The car has no steering. The switches are the only thing directing it. If a switch is late or misaligned, the car goes to the wrong track, and the yard has to stop and fix it by hand. The car picks up speed on the way down. Too much speed, and it will slam into the standing cars at the bottom hard enough to rupture cargo. Not enough speed, and it will stall in the bowl, forcing a locomotive to come push it the rest of the way, a process called trimming the yard. This is where the retarders come in. A retarder is a pair of heavy steel brake clamps bolted to the rails on both sides of the track. When a car rolls through the retarder, the clamps squeeze against the wheels and slow it down. Hydraulic pressure controls how hard they grip. A hump yard has multiple retarder stages between the crest and the bowl, each one fine-tuning the speed. The system measures every car that crests the hump. It weighs the car on rail-mounted scales. It calculates the rolling resistance based on bearing condition, wheel type, and the number of axles. It checks the wind speed and direction. A headwind on a cold morning can stall a light empty hopper car before it reaches the end of a long bowl track. Cold steel wheels on cold steel rails create more friction and the car loses momentum faster. A tailwind on a warm afternoon can push a heavy-loaded tanker into the standing consist at dangerous speed. Warm bearings spin freely and the car arrives at the coupling point faster than expected. The computer recalculates retarder pressure for every car, every time, adjusting for weight, speed, air temperature, wind, and the distance the car has to travel inside the bowl. No two cars get the same treatment. A loaded grain hopper and an empty boxcar rolling off the same hill require completely different braking profiles, and the system has roughly 15 seconds to calculate and execute each one before the next car crests the hump. At Bailey Yard, this process moves 4 cars per minute. One car every 15 seconds, rolling off the hill, finding its track, and coupling to the train it will leave on. That coupling is not gentle. The target speed for a car reaching the bottom of the bowl is 2 to 4 miles per hour. That sounds slow. It is not slow when the object rolling toward you weighs 100 tons. At 4 miles per hour, a loaded freight car delivers approximately 500,000 pounds of force at the coupler face. To put that in terms you can feel, that is the weight of 35 pickup trucks concentrated on a steel knuckle the size of 2 fists. The only thing absorbing that impact is the draft gear. Every freight car in North America carries one inside its coupler pocket. It is a spring and friction assembly, a stack of metal and rubber designed to compress on impact and release the energy slowly enough that the cargo stays intact. Standard draft gear, rated to Association of American Railroads specification M901, gives the impact 2 3/4 to 3 1/4 inches of cushion. That is less than the width of a closed fist. When the draft gear runs out of travel, it goes solid. Going solid means the spring bottoms out and the full force of the collision passes directly through the car frame and into whatever is riding inside. Coal and grain absorb the hit without damage. Steel coils on a flat car shift forward on their cradles. New automobiles inside a tri-level auto rack lurch against their chains and wheel chocks. Liquid inside a pressurized tank car sloshes forward in a wave that hammers the front head of the tank. The draft gear is rated for impacts up to 5 miles per hour. At the target coupling speed of 4 miles per hour, every single coupling, thousands of times per day, happens at 80% of the structural failure threshold. The margin between a sorted freight car and a ruptured tank is the width of a fist. That is what those 3 words are about. There are cars that cannot survive the process. Hazmat tank cars carrying chlorine, anhydrous ammonia, and vinyl chloride are at the top of the list. The federal regulation exists because a coupling impact that goes solid can crack a tank head and release pressurized poison gas in the middle of a rail yard full of workers. What happens inside the draft gear when a loaded auto rack couples at the bottom of a hump bowl? That is the question the railroad spent decades engineering around, and the tolerance they settled on is thinner than most people would accept. Auto racks are loaded through one end in a method the industry calls circus loading. Workers drive each vehicle into the car, one behind the next, and strap them to the deck with wheel chocks and tie-down chains. 3 levels of cars, bumper to bumper, held in place by straps and friction. A single 4-mile-per-hour coupling jolt hits every vehicle on every level at the same instant. The chains catch the worst of it. When they do not, the damage report goes to the insurance company and the consumer price goes up. Depressed center flat cars, the ones built with a low center section to carry oversized transformers and industrial equipment, cannot go over the hump at all. Their dropped floors would scrape the crest of the hill on the way over. Schnabel cars, the massive multi-axle carriers designed for reactor vessels and generator stators, are banned from the process entirely. Every hump yard has a dedicated bypass called the escape track. It is the route for cars marked "Do Not Hump." Workers are supposed to pull those cars from the consist before the train reaches the crest, then flat switch them around the hill on level ground. Railroad workers report that the escape track has the rustiest rails in the entire yard. The throughput pressure of sorting hundreds of cars per hour makes it expensive to stop the flow for a single car. The track exists. The regulation requires it. It does not get much traffic. All of this happens at a scale that is hard to picture. Bailey Yard in North Platte, Nebraska, is the largest railroad classification yard on Earth. It covers 2,850 acres, enough land for 2,155 football fields laid side by side. It stretches 8 miles from end to end and holds 315 miles of track. If you laid those tracks in a straight line, they would reach from North Platte to Omaha, clear across the state. 2 humps sort 3,000 cars every day. The eastbound hump stands 34 feet tall and the westbound rises 20 feet. 17 receiving tracks feed inbound trains into the system. 16 departure tracks send outbound trains back to the main line. 14,000 cars pass through every 24 hours. 139 trains arrive and depart daily. 2,600 people keep it running, most of them responsible for nothing but the sorting, inspection, and assembly of freight trains that cross the continent. BNSF operates 8 hump yards across its 32,500-mile network, all of them upgraded with terminal process control automation. In April of 2021, the BNSF hump yard in Galesburg, Illinois, broke every facility record ever set. 1,888 cars humped, 1,923 pulled, 1,721 arrived, and 1,847 departed in a single day. In 1975, North America had 152 active hump yards. That number dropped to 122 within a decade as railroad mergers eliminated duplicate facilities. It fell to 72 in the early 1990s, then 59 at the turn of the century as intermodal and unit trains replaced loose car traffic on many corridors. Today, 36 remain. 3/4 of the hills are gone. More than 3/4 of the gravity sorting systems that once built American freight trains are gone. The stencil is still required. The federal regulation is still in force. 1 in 4 freight cars in North America is a tank car. 2 million hazmat shipments move by rail every year. The next time you sit at a crossing watching a freight train roll through your town, look for those 3 words: "Do not hump." Now you know what they mean. A 34-foot hill, a 100-ton car rolling by gravity, a controlled collision at 4 miles per hour, and a margin of 3 inches between a sorted freight car and a ruptured chemical tank. Those 3 words are the only thing between the physics and the cargo, and 36 hills are still running. Subscribe to American Iron Works for more of the engineering. Behind the freight system you see every day but never think about.